for Kappa in the Cork Institute of Technology.
Thanks, Dennis. So I'm going to give you a very brief overview of the type of work we do surrounding the use of photonics in some of the projects we have and how we feel that they can add value and efficiency to some of the processes that I'm sure many of you come across in your day-to-day activities. As Dennis says, we're based in Cork Institute of Technology and we're a technology gateway. So essentially, for those of you who don't know, this is a scheme that was set up by Enterprise Ireland some years ago to try to add value to the research that's being done in the Institute of Technology and to try to bring that more to the fore for industry. So we're specifically tasked with going out and talking to industry and trying to help them with their issues and their problems and to understand what benefits and what support we can bring to them. So at the moment there's 15 gateways, so they're spread around Ireland, as you can see in the map there. We've recently added 3 new ones, as well as 12. And we all have our own basic, fundamental core theme, if you like, and ours is photonics. You'll see there's a few there. Shannon ABC have biopharma, there's a group in water that do applied materials, they're here as well. A couple here in DIT that do Micro Centre, Letterkenny and Athlone do wireless communications. A huge variety of themes running through the 15 centres. And I think the important thing to note is that once you talk to one centre, you're actually talking to us all. So it's important for us to make sure that if you have an issue that we can't help you with, we always try to push you towards the person who can to give you insight into where that can be done. As I said, our idea is to deliver R&D solutions to industry. We have approximately about 2.5 million euros worth of grants ongoing in Kappa. That's through direct funded, innovation partnerships, vouchers, European studies, the variety of systems that you can see. And the process to become a gateway is quite competitive, so we would feel reasonably good at what we do, so we want to be able to help you guys as well by using that experience. We're co-located between Cork Institute of Technology primarily and the Tyndall Institute as well, for those of you that know Cork. It's down where it used to be the old National Microelectronics Research Centre. So we have half our labs there and half in CIT. And the research is split basically 50-50 between industry-led, which primarily comes from CIT, and the more fundamental research that comes from Tyndall. And that's important, and I mentioned that in a slide just time as to why we have 2 different arms and 2 different branches on that. Just some numbers on the kind of work we're doing, publications, people, the sort of engagements we have around the nationally and internationally. Again, happy to talk to you if you're interested in that sort of work. Photonics itself, quite straightforward. The generation, manipulation, if you like, or control and detection of light. It's a huge market for photonics. The direct market, which involves lighting, sensing technologies, is around 350 billion, 65 billion of which is produced in Europe. So there's quite a significant chunk of change, if you like, to be had from working in the photonics area. And what we're finding is that there's a very, very broad range of applicability for photonics. We're moving into other areas. And the reason for that is because essentially all materials have some kind of a spectrum response. If you shine light at a material, something changes about the material, or something changes about the light, and you can tell what's going on by looking at the reflected light or the transmitted light through that. Very, very simple, very straightforward process. The key to understanding that is knowing what it is you're looking at when you look at the results. It can be very cheap and compact, simple light source and detector with your medium in the middle, so very, 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 very easily manipulated, very, very easily set up. Because of that, it's got a small footprint, so you can integrate it at or inline processes where applicable or where suitable. That can be a little trickier than maybe we put down on paper, but it's certainly possible. And it's non-invasive and non-destructive, and that's a key part. You can continue on your process chain after you've investigated whether your material or your element or your process that you have in it. So it's very, very important that you're not disrupting the flow of light. You can either take something from your process chain and look at it, or you can put it back in and keep going with it. Optical solutions are applicable, as I said, a wide range of areas. Food and pharma, biomedical, and in particular now we're seeing agriculture. All these industries some are very, very technically minded and some are just becoming so. But the applicability for photonics is very, very wide ranging, and I'm going to give you just a couple of examples of those in the short time that I have here. So just some of the key points about what we do. We provide industry with an experienced R&D platform. We also assist industry in accessing funding, and that's something that especially small enterprises are not necessarily okay with. The mechanisms and the availability of funding that's there to carry out R&D or to be able to access that, and there's quite an amount of that. And I think it's very important that if you have a small or medium business, that you understand what those mechanisms are. They're really excellent, in fairness, and I think everybody should understand what they are. We're very, very happy to talk to people about those. We provide access to specialized test equipment. Sometimes it can be as simple as us having a technique or capability that the industry doesn't have, and we're very happy to work on that. And we also, and I think this is probably the most important part, we develop the next stage of research in order that it's industry ready. So if we were to spend all our time just solving industrial problems as they exist now, we wouldn't have anything new to bring to the fore for you guys afterwards when the industry changes, as it inevitably will. Change is if you're not changing, you're standing still. If you're not creating extra efficiencies, if you're not tweaking that extra few percent as you move along, it's, people understand that you need to have that. And it's up to us to make sure that there are new techniques, new solutions, new approaches that we can apply, that we can work with you and develop and tailor to suit your needs. So, as I said, just to look at a particular example, and a great example of how we might work with a particular industry. So this is a company that's based in Middle Island in Cork, called Photonics. They're specifically an LED, a laser illumination company. They're quite broad. They've got a fairly significant revenue. This was in 2012, is the most recent figure I have. But we started off with essentially a one-day initial consultation with them, and that was free. It was basically them to come in, say we have an issue with this, we'd like to discuss this with you. That developed into a feasibility study, which was solely funded by EI in around 9-10,000 euros, and that developed into an innovation partnership for the research and design of a new product that they wanted to bring to market. It was a high-power UV curing device. So that was very, very successful. We signed a license, a technology license with the company in that, and they launched it at Photonics West, which is the big industry photonics seminar that's held in the States every year. They launched it last year, and so that's coming up again very, very soon. And at the moment now we have 3 further investigations. We're working on another innovation partnership. So you can see how it spreads and grows through the interaction. Once we start to engage with people, that's important for us. If you can come and tell us what issues you're having, we can try and help you with those. Very, very simple explanation of why we feel some of the technology we have are good. They're very broad. They're technology platforms. So if you look at what we have here on the left-hand side, you have what looks like essentially the experiment that we set up to test a particular principle. Now this is for a local company again in Cork. They wanted to look at sensing in a particular environment. We did a benchtop experiment, like on the left-hand side, and we tailored that into something that could be handheld and taken around, which is the unit on the right. So it's just a way of taking the measurement that you've proven in principle on the bench, putting that now to somebody on the environment, and that is exactly the type of thing that we're good at. Very, very simple, very straightforward, but very, very important to the company. This is something that they really want to do. And we added just a simple graphical user interface to that. So what they have now is a remote unit that they can either leave in place, or they can connect to the cloud, but they can download the particular data that they want to have for that particular environment. And it's very, very important that they're able to do that. The key of this is if you look at how it's broken down, you have various different parts to that. You have the interface, you have the graphical user, you have all the connections. But what you have in that top left-hand corner is the photonics sensor. So you can imagine everything else beyond that is the same. And if you change that sensor to suit whatever it is you want to sense, you've now got a totally new problem. And a lot of these solutions already exist. A lot of these sensors for sensing, say, gases and mixtures, or looking at detection of light in itself, or changes in light, already exist. So it's a matter of just slotting these in and out. They can be interchangeable, and they can be quite easily manufactured, and they can be cheap. So this is the beauty of it. It's a base platform technology, and with small changes it becomes very, very widely applicable to other industries. Slightly different on that is a process analysis technique that we use. So this we've used, and we've looked at it in terms of food and dairy products, so in particular milk and cheese. So we've looked at spectroscopic techniques, again, shining a particular wavelength of light at a material, looking at the light, looking at the changes, and that informing us about what's happening. Very, very simple and very straightforward, and reasonably well understood once you know where to look. So for milk, you can look at things like fat and protein content, which are also very, very useful in terms of both the quality of the milk you're getting and the quality of the products that you want to manufacture. You can look at additive components. You can look at different types of fat and substitutions of fat. You can look at whether they're naturally occurring or whether they've been substituted into it. So you can do that also with cheese. You can look at characteristics of cheese. This is it's a very, very new technique that we've looked at. And you can look at also the mineral composition. This can be important depending on who your target market is, who your actual audience you're looking for. Very simple project we've undertaken recently with a company is to look at cheese maturity. So the company were finding that the cheese itself was performing differently depending on what processes they were using it in and depending on the cycle they found it in. Nominally the same cheese they were receiving each time, but very, very subtle differences in performance. And because this was a customer-orientated product, obviously they don't want the customer to have a bad experience with the product, so they want to make sure that everything is right on the way in. So what we were able to do was make some very straightforward spectroscopic measurements, do some tests on those, and essentially look at a maturity cycle for the cheese. So we were able to pick a window for the customer, to tell them this is the optimum time that you use your cheese in, and this is your best performance. That also gives them information on when to order and when to look at their stock. So rather than holding a lot of cheese they might buy in bulk and was cheap, but will ultimately be useless to them because it's past their optimum time, they can now order in smaller batches and be more focused and be more savvy about what they have. As I said, we developed a model for that, and we were able to give that process to the company, and that's very, very successful. So we're going to look at that over a period of about 12 months, and again we'll refine that model as we go. One of the simple processes that we use this, and I'll picture this quite quickly because it's only important when you see the actual product itself, but it's chemometrics. It's looking at what do we pick out from those spectra. What particular, there's a huge amount of information in that spectrum. But what components do we look at? If you look at the principal components, you can make relationships between those and the actual outcomes you want to see. And it's seeing the wood for the trees, if you like. There's a huge amount of data that's available. People somehow like data, it gives them a fuzzy feeling when they've measured a lot of things. But you like to be able to pick out what's important, you'd like to be able to pick out what's relevant to you. And that's what this process can do. This is something that's applicable across all the variety of what we do. One final example, this is a combination of technology platforms. So if you think of guide wires, medical guide wires have been around for decades. The photonic sensors, as I said, that we use, again around for decades. You combine those, and now you have a very powerful diagnostic tool. So this is a project we did in conjunction with our colleagues in Tyndall and Lake Region Medical. We just put the photonic sensor on the end of the guide wire, and using a few mathematical formulations and tricks, we were able to measure the blood flow at the patient's arm in situ as the stent or as the unit is being installed. So that's a combination of two very well-known technologies, but it gives you something new, something inventive, if you like. So if you consider this in a more simpler form, this is a probe that's being pushed down the cylindrical pipe in some very broad sense. Your artery is a cylindrical pipe, the probe is a guide wire. And you can change that now if you change the probe to being something like a fibre optic, and the pipe can be anything that holds the material that you want to inspect. You now have a very, very broad platform that you can use to have diagnostics. So again, this is something we're working on for looking at things like pH and the constituents in contaminated water, etc. So again, things we're using there. So as I said, the photonic solutions are very, very applicable across a wide range of disciplines. It's key for us to have the industry understanding combined with the kind of smart research we do. The smart research is only so good if we can't apply it to something. That's essentially our remit. And cooperation, in my mind, is the key for that. So very, very happy to take some questions. We have a stand at 26C, it's over by the coffee, so if you're wandering that way, we're very happy to talk to you. Thank you very much.